In this example, we're going to be looking at sums or differences of radicals that do not have the same radicand or the number underneath the square root sign. So we're going to have to simplify at least one of them to make it look like the other. So when we look at the square root of 5, the square root of 5 is fully simplified. There are no factors of 5 that are perfect squares. But when I look at square root of 20, that is built up with um, factors that are perfect squares. So when I look at 20, 20 is not on my list of perfect squares, but I can cut it in half and make 10 and then start at 10 and work my way down. 9 is not a perfect square, or it is not a factor. Sorry, 9 is a perfect square. 9 is not a factor of 20. But if I go to 4, 4 is. So I can rewrite this as negative 2 times the square root of 4 times 5, because 4 times 5 is 20. The square root of 4 is 2, so we can go ahead and bring that 2 out, and we leave the square root of 5 in. And negative 2 times 2 is negative 4, square root of 5. That's important. Okay, so now we're going to put that in there. Negative 4 square root of 5 minus 2 square root of 5 is equal to, well, negative 4 minus 2 square root of 5. Negative 4 minus 2 is negative 6 square root of 5. Same thing on part B. We look at the square root of 7, that's fully simplified, but 2 square root of 63 is not. 2 square root of 63 can be rewritten as the square root of 9 times 7. 9 is a perfect square of 63. And so this would be 2 times the square root of 9, which is 3, square root of 7, which would give us 6 square root of 7. So we would have 10 square root of 7 plus 6 square root of 7. That would be 10 plus 6, 10 plus 6 square root of 7, which is 16 square root of 7. 16 square root of 7. Then on part C, same basic idea. We're going to simplify the radicals. We'll start off with the square root of 50. So we have 3 square root of 50. Divide that in half. 50 is not on my list of perfect squares. Divide it in half and I get 25, which is. So this can be rewritten as 3 root 25 times 2, which is the same as 3 times the square root of 25, which is 5 root 2, and this is 15 root 2. On to the next radical, square root of 18. Well, the square root of 18 can be rewritten as, well, 18 divided by 2 is 9, and 9 is a perfect square. So we'll have 9 times 2. And the square root of 9 is 3, so we'll have 3 root 2. And then last but not least, the square root of 27, and that is, again, not on my list of perfect squares, but it can be broken down into 9 times 3. Square root of 9 is 3 root 3. So now we're going to put those three simplified radicals in a line. 15 root 2 plus 3 root 2 plus 3 root 3. One of these does not belong. One of these is not going to be able to be combined with the other two. So we look at the radicands, and I see square root of 2, and I see square root of 2, and I see square root of 3. We cannot put the square root of 3 with the square roots of 2. So we're going to put the square roots of 2 together. So 15 plus 3 square root of 2 plus, and then we'll just leave 3 square root of 3 by itself. 15 plus 3 is 18. 18 square root of 2 plus 3 square root of 3. And that will be your final answer. So guys, that's it. That's how you do it. If you guys have questions, please let me know. Otherwise, here are your try it problems. So a couple problems for you to try out. See if you can come up with the right answer. And if you have questions, please let me know in class. Thanks.